So when we have a pure metal, all the particles that make the metal up are the same size because they're all the same particles. And this means these layers can slide easily over each other. When we have an alloy, alloys are mixture, the particles are different sizes. And that means the layers are disrupted, and therefore the layers can't slide easily over each other. So if I was to try and slide this layer here, you can see it's going to be difficult to do because there's larger particles in there preventing it from moving. And because it's harder to slide, therefore it becomes a stronger material. So there's 3 marks. The 3 bullet points you need to say are that alloys contain different sized particles. This means that the layers are disrupted. And then the layers do not slide as easily, so it is stronger. Okay, so this calculation, we have an alloy, and in the alloy, we're being asked to find the amount of aluminium if we are told that 2% of the alloy is magnesium. So the first thing we've got to do is work out what 2% of this original mass is. So to do that, we take the mass that we've got and multiply it by 2 divided by 100. So if I do it on my calculator now, so 695 times by 2 and then divide by 100, I'm getting here 13.9, and that's grams, and that is of magnesium. So in order to find out the amount of aluminium, all I need to do is take that original mass, 695, because that's the aluminium and magnesium, take away the 13.9, so 695, take away 13.9, and that's giving me an answer of 681.1 grams of the aluminium. Okay, so we have a graph set up for us to use to help us answer these questions. And the first thing is to describe the relationship between the relative strength of the alloy and the percentage of magnesium. So as you can see from the graph, as the mass of magnesium increases, then the relative strength increases. That's all we need to say for 1 mark for each of those two. So as the percentage mass of magnesium increases, that gets us 1 mark. The strength of the alloy increases. Second part, we've got to use the graph to find the percentage by mass of aluminium, underline that bit for a minute, when the strength is 103. So the first thing to do is go on the graph and find where the relative strength is 103, which is here. And then you take a line across to where it meets the graph, and then you bring a line down like I've got here to show the actual value on this axis. So this shows me that when the strength is 103, the percentage by mass of magnesium is 3%. So let me just write that bit down first of all. So we've got 3% magnesium at that point. Now my alloy is aluminium magnesium, so this means that 97% must be aluminium. And the question wants me to give a percentage by mass of aluminium. So in terms of marks for this one, you get 1 mark for pulling the 3% from the graph, and you get another mark for getting 97% aluminium is left over. So there are 2 reasons we electroplate objects. The first reason is it improves the appearance. So we could add a nice layer over a metal and make it appear to look nicer. And the second reason is that we can protect the metal underneath from corrosion. So we can put here protects, I'm going to call it the base metal, that's the metal underneath the layer that we put on, protects the base metal from corrosion. Okay, and they're the 2 reasons that we would use electroplating.